Hey guys, so these are your separating mixtures notes. We're going to talk about the analysis of mixtures. Just to remind you, mixtures, to do a definition recap, is a combination of two or more substances where each substance retains its own chemical and physical properties. That allows us to isolate those different substances and analyze the components of the mixture. All of these, um, these methods for separating mixtures, they apply to homogeneous and heterogeneous mixtures. But not every method can be used on every mixture. So do pay attention to which techniques work best for homogeneous mixtures and which work best for heterogeneous. Some of our methods include using a magnet, filtering a mixture, decanting, evaporation, using a centrifuge, chromatography, and distillation. We'll talk about some of those now. First of all is filtration. Filtration is a technique that uses a filter paper to separate a solid from a liquid in a heterogeneous mixture. Next, we'll talk about crystallization. Crystallization is a separation technique for homogeneous mixtures that results in the formation of pure solid particles from a solution containing the dissolved substance. Next, we can talk about distillation. Distillation is a separation technique for homogeneous mixtures. It's based on the differences in boiling points of a substance. You can also use something like sublimation. Sublimation is the process of a solid changing directly into a gas, which can be used to separate mixtures of solids when one substance sublimates and the other substance does not. And lastly, for our separation of mixtures portion of these notes, we're going to talk about decantation. Decantation is a process used to separate a heterogeneous mixture of two immiscible liquids. Immiscible means that they are not soluble in each other. They form layers, like you can see in the picture. Or you can use decantation to separate a mixture of a liquid and a solid, such as a suspension. You can separate these mixtures by either pouring off the top less dense liquid or by removing the top liquid with a pipette. So once we analyze these mixtures, sometimes it can be really useful to know how much of something is contained in our mixture. And the way that we do that is we can calculate the percent composition. The percent composition will tell us how much of each substance is going into the whole mixture. Chemists often need to know how much of a part is in the whole. For example, flavor chemists need to know how much of each ingredient goes into a can of Mountain Dew. And fragrance chemists, for example, need to monitor how much of each ingredient goes into a bottle of perfume, so that not only so that it smells nice, but so that it functions properly. It's not too oily. The correct substances evaporate off your skin. There's not too much of anything. In order to calculate our percent composition, we go ahead and do a mathematical formula. So the percent composition is how chemists determine the part that's in a whole mixture. And we do that by mass percentage. So the percent composition of a substance in a mixture can be calculated by dividing the mass of the part of the mixture by the mass of the whole mixture. For example, let's look at a problem here. You can add these problems to your notes, or you can just follow along. For example, a bowl of Cheerios weighs about 28 grams, and a student was able to separate out all of the iron with a magnet. The cereal contains about 0.00809 or 8.09 milligrams or 0.00809 grams of iron. What is the percent composition, or the percent by mass, of the iron in the cereal. So first we have to find the mass of the part. The part we're interested in is the iron. So the iron we know weighs 0.00809 grams. Then we have to find the mass of the whole mixture. The mass of the whole mixture is the whole bowl of Cheerios. Just counting the Cheerios, that is 28 grams. Then we can use our handy dandy formula for part divided by whole times 100, and that'll give us the percent composition. So we take the part, 0.00809 grams, divide that by 28 grams, and multiply the whole thing by 100 because we are talking about the whole bowl of Cheerios. That would be 100% of the Cheerios we're analyzing. That gives us 0.028%. So by mass, we can say a bowl of Cheerios is 0.028% iron. Whenever we're separating any types of mixtures, we're going to end up with a little bit of laboratory error. Errors are unavoidable. It's impossible to make sure that you isolate every tiny little bit of each particulate. Some things get stuck in glassware, things get lost in transfer. There's always going to be a little bit of error. Scientific error is any difference that we see between the observed values being the experimental or the actual values we get in lab, and what is true in nature, our theoretical or our accepted values. Error causes results that can be inaccurate or misleading. That's why we want to calculate our percent error. We want to see how accurate our actual answer is compared to an accepted value. So to repeat, the error is equal to the difference between the actual value and the experimental value. When we do our error analysis, like I said, in every experiment, some error is going to be present. The values or measurements that we take while running an experiment are considered your experimental values. That's the value that you measured, your data says exists in the mixture. The theoretical value is what is accepted to be true for the experiment, or very often it's the value that's calculated or known to be accurate. For example, in a mixture, if someone made the mixture, they would know exactly how much went into the mixture. We could use that as an accepted value. The formula that we use to calculate percent error is equal to the theoretical or the known value, the accepted value, minus the experimental value or the actual value, divided by the theoretical value again, and then multiplied by 100. Please note that the two solid straight lines on either side of your fraction there, theoretical value minus experimental value divided by theoretical value, mean you take the absolute value of that measure, of that calculation. Errors should always be reported as a positive value, okay? We just want to know how far away we are from the actual answer. So to sum up, percent error is the percent that a measured value differs from the accepted value. Remember, your accepted or theoretical value is a quantity used by the agreement of the scientific community. It's what you're supposed to get. Experimental is the actual value that you get when you're running the experiment. It is a quantitative value or a measurement that you've made during the experiment. It's what you actually got out of your experiment. The goal is to get that percent error as low as possible. Be as careful as you can. Transfer as much product as you can and minimize any losses from spillage, from things getting stuck in a filter paper, things like that. Okay, we will practice this in class. We'll see you then.